All right. It looks like we're recording now. Welcome everybody to the July Triton Community Meetup. We have a nice lineup of folks willing to give their presentations today. We'll learn some interesting new things about Triton, and then we're going to have, I think, at the very end, a nice surprise and find out more about the Triton Developer Summit coming up later on this year. I'm Bill. I'm your moderator. Our first talk on the agenda will be a talk about Gluon. Jeff New will be presenting it. He's from OpenAI. Jeff, do you have a presentation you'd like to give, or would you like to just talk it out?
I do actually have slides.
Excellent. What more could you ask for?
Share my screen. All right.
Hey, Bill. Sorry to cut in.
Shoot.
Yeah, so I actually have to leave in about 10-15 minutes. I want to present the Triton Developers Conference. Can we do it first? Can we do it
excellent,
first thing right now?
Yeah, thanks, Ofer. I forgot to ask you that early. Jeff, if you don't mind, yeah, can we move you back a little bit?
I can go later.
Great, thanks. Ofer,
Yeah, cool. Thanks.
Really
Sorry about that. Just a very quick announcement, just so everyone knows.
Okay.
And then I have to eject and go to a manager's meeting. So sorry about that.
No worries.
Good. So I just have one slide. Let me just show it. Okay, yeah, can everyone see the slide I have? Yeah, okay, awesome. So yeah, I'm very excited to announce our annual Triton Developers Conference. This is the third year that we're holding the conference. This year it'll be hosted by Microsoft at the Microsoft Silicon Valley campus, which is in Mountain View, California. The conference is, primarily an in-person conference, and will take place in our Silicon Valley campus on October 21st. That's the day before the PyTorch conference, which is in San Francisco. So the idea is that if people are, flying out to California, the San Francisco area for PyTorch, then this is the one day before. And, Mountain View and San Francisco are pretty close. And depending on whether, we'll probably have a survey asking if people are staying in San Francisco, we may have buses. So, if you're flying out to the PyTorch conference in San Francisco, you can stay in your San Francisco hotel, and we'll bus you back and forth to Mountain View. Or if you're coming special for the Triton conference, which is always a good idea as well, then get a hotel, of course, close to the venue, and don't get a hotel out in San Francisco. But in any case, it's not exactly co-located, but they're kind of close. So it's supposed to be convenient for people to attend both if they want to, but I think there will be a lot of people coming, especially for the Triton conference as well. Our auditorium in Microsoft SVC is set up to hold up to 500 people. So it should be, pretty big venue. Yeah, I just wanted to invite everyone on this call to come and attend in person if you can, make travel plans. This is, the big in-person annual event for our community, for the Triton developers community. In addition to a fantastic, exceptional lineup of talks, this is your chance to mingle and meet other, professionals across the industry who are working on Triton, or, in Triton, on extensions to Triton. This is the one big annual event, so please consider attending. It's a little bit unfortunate that this meeting is today and not a week from now, because I was hoping to be ready with everything, and we're just a little bit late. So I don't have a registration website URL to share with you today, but it's imminent. It's very, very close. So, there's a vendor that Microsoft works with that does our registration. It's a professional, registration vendor, and they're just setting up the registration website. So it should be online very soon. We'll also have a website as well pretty soon with all the details, and that'll be the place where you go and get update on all the information on the conference. So these things are coming up soon, and just stay tuned for the link. I'll share it out on the Slack channel and on every channel I can get my hands on, and please also send it to your peers and so on. So the link is coming, and we're just not ready just yet with website or registration. The other thing that's very imminent is the invitation letter. I know that some people may be planning to come internationally and may need to get visas for the US. So there's an invitation letter that will be available to you that will allow you to go to the consulate and get your visa and so on. So also that will be hopefully ready, maybe even this week, and all that information will be on the website. Just as a little bit of a teaser, we already have an exceptional lineup of speakers, confirmed speakers, and we're finishing the program. Just a few final touches. NVIDIA will give a talk on optimizations that they did in Triton for Blackwell, and AMD will talk about backend optimizations for the MI300, 350. So those are really, really exciting kind of low-level technical backend talks. We'll have a Gluon talk from OpenAI. LinkedIn will talk about the Liger kernel open source project that they have. ByteDance will come and talk about Triton Distributed, which is a very, very exciting extension to Triton that many of you know about. Meta will talk about Helion. We have a community talk from GPU Mode on building communities for Triton community and other GPU communities, and some other talks that I'm not prepared to announce today, but this is not the full lineup. Just these talks. I mean, man, I would love to be an audience member and attend and hear about all this great stuff in person, be able to talk to the speakers afterwards and ask my questions and chat with people and so on. And it's going to be better than this. So we're going to have even a few additional talks. And then just hanging out with each other in person is of course one of the main reasons to come. So that's my announcement. Again, sorry that I don't have all my ducks in a row just yet, but it's very, very close, and I'll send out all the links. And yeah, if there are any quick questions, I could answer, and otherwise I'll be done.
Okay, well, looking around, do folks have questions? I'm sure there were some questions that I know that previously the people had. Raise your hand, or just simply shout them right out.
I don't see actually, I do see the raise hand. So I wanted to know, are you going to be doing any tutorials? So something more like how to write a Triton kernel or how to do performance analysis, things like that?
So right now we don't have that planned on the schedule. We had so many new and exciting Triton-related technologies that were, either came out or kind of exploded in the last year, and it already kind of filled our entire schedule. We have a little bit of slack, so I'm working with Phil and others on the program. Right now we have more, more of these cutting edge new technology talks than we have time. So I doubt that we'll be maybe next time we need to extend it to 2 days, but right now it's a 1-day conference, and just talking about all the latest tech around Triton has really filled our schedule. So there's no tutorials planned right now. Also, I think it's becoming a conference for professionals, for people who work in this area. So, it's a good question whether one of the goals of the conference should be to pull in non-experts and teach them and train them and do like the basics as well. Right now, these talks will be technical. These talks will be kind of kick-ass, interesting, all the cutting-edge stuff. So it really is geared for people like us in this meeting who know this stuff and already kind of live and breathe it and just want to see what the latest and greatest is. So that's kind of the focus that's shaping up right now.
One thing I can add here is I think we do want to have like a tooling, or like some talks on tooling like Proton that will cover like usage, I guess, and like how to optimize performance and guidelines, and maybe we can try to have some, depending on how much time the presenters have, just have like some material that goes with the talk that people can use, I think, to try to reproduce the results or something.
Thank you.
All right, I think we see another hand up there. Adnan, do you have more? Or okay. The second hand goes to Cece.
Yeah, hi. I had a question about actually two questions. One is last year when we had a conference, there was two groups of people sort of. One is the developers and one are the user of Triton. And I think the talk was very much geared towards the developers and trying to get people to contribute. And there's not a whole lot of coverage for trying to spread more usage of Triton. So I don't know if there's any plan to extend more to the user of Triton. And second question is there any social aspect to the Triton conference? Like, is it going to be all day just sitting there listening to people talk, or is there like more interactive, like conversation that happens that we can help to facilitate more for the attendees?
Yeah, great questions. Thank you very much. So I think, just looking at these confirmed talks over here, definitely some of them are touching the deep internals of Triton and will interest people who are building backends and trying to extend Triton. Specifically, the first two talks are, going to discuss things that happen deep inside Triton. And then there's a set of talks that are really around new tools and the Triton ecosystem. If you think about, Helion, if you think about the lighter kernel open source library, these are things that will be very interesting for users of Triton who want to, be empowered with new tools. Triton distributed is very useful for users. I don't think, you'd go to the Triton distributed talk to make Triton distributed itself better, but you would perhaps want to use it if you're trying to, train on big fleets of GPUs. GPU mode is going to be a community focused talk on building communities and how we communicate offline, not at the conference, and all the philosophy around that. So I think it'll be a very interesting. I think also the users of Triton would benefit from looking a little bit under the hood and understanding what's happening under the hood, but maybe it's not their primary focus. So I think this will cater to both types of communities. But I take your comment here, and I think we should, as we're finishing the program, just double check and confirm that we're, catering to both types of audiences. Definitely, the goal is to have, for both types of people to come and feel that they got a ton out of this conference. In terms of the social aspect, so we're locking down the speakers first. That's kind of the bread and butter. The core is the technical content. It'll be a full day. It's not going to be a full day packed with talks. We're going to have lots of breaks. There'll be coffee breaks. There'll be a lunch. I hope that we can get a happy hour at the end. So there'll be a lot of time to for unstructured type of social interaction, and we'll definitely build the program in a way that encourages that. Right now, we don't have plans for any, more structured social engagement, like, creating little pods of people and kind of giving topics and forcing them to talk on or not forcing, but, encouraging certain topics or so on. So right now, the idea is to have structured talks where you sit down and listen, and then lots of breaks where you go off and talk to peers and grow your network and things like that. But it's honestly a little bit still in flux. So, we'll have a much better idea, hopefully by the end of next week when everything's published on the website. I hope we have a finished, final answers to all the questions. If people have, any suggestions or any ideas from other conferences and other communities of how to do social interaction in a way that's different than just creating lots of time for it, then please feel free to reach out to me or to Phil or to anyone, and we'd love to hear the ideas and see if we can do it. If we don't do it this year, we can also kind of set it up for the next one and try to build this better and better as we go from year to year. This is my second time organizing this. Phil's involved every year. I was involved with the first one and now the third one. So there's kind of a group of us that is that's doing kind of the organization here, and then the folks from Meta and Adnan have done a wonderful job last year, and next year I think it'll be Meta's turn again, maybe. I hope, and we're learning and making it better. So even if the even if it's a little bit too late to make drastic changes for this year's conference, it's always good to hear these ideas so that we can plan better for the future. So
That's
don't be
good.
shy. Please let us know. Yeah.
That's good, Ofer. Anything else, CC?
Just real quick, GPU mode, is that led by Mark Serafin?
Yeah.
Yeah, I think so. I think Mark will be participating.
Okay.
Yep.
Okay. I think Simon has a question, and then we'll probably let you then get off that.
Yeah, wrap it up. All right, thank you. Yeah, go ahead, Simon.
Well, it sounds very exciting. Just curious what, with the PyTorch conference being at the same time, is there going to be any content on that side? Are we coordinating, or is there any workshops or anything that we're doing on that side?
No, we're not coordinating the conferences other than, deliberately making an effort to make them geographically close to each other and on adjacent days, just with the expectation that a lot of people will want to attend both, and just making it easy for people with travel and so on. So, the PyTorch conference is already kind of a bigger, more established conference, longer, costs money to attend. Ours, we're kind of piggybacking a little bit, and they set the dates, and then we just snapped. We said we'll either be the day before or the day after, and the day before is what worked out. And we're hoping that PyTorch will draw a lot of people that will say, hey, I'll invest another day of travel and go hear about Triton. So we're hoping that'll increase our attendance. I mean, I'm not worried. I think we'll fill the room anyway, but just to make it a little bit easier for people. So that's the only goal. There's no shared workshops planned, and right now we're not coordinating anything other than the dates and trying to make it close geographically.
Okay, cool.
All right.
Sounds good.
Thanks.
All right,
Thanks, everybody.
Thanks very much, Ofer, for the presentation, and once again, looking forward to all the information coming out over the next couple of weeks.
Absolutely. Yeah. Thanks a lot. Thank you.
Thanks. All right. So for our next talk, we've got Jeff. Jeff's going to give us a brief review of, actually, like I said earlier, telling us what's going on with Gluon. Everybody's really interested in hearing what you got to say, Jeff.
Simon has his hand up.
Oh, Simon, sorry. Is it still up?
Sorry, forgot to turn it off.
It was a pre-question for you, Jeff.
All right, can everyone see the slides?
Yes, looks good.
All right, cool. So this is an update about Gluon. Some of you may or may not have heard of it. It's something that the Triton team, some folks on the Triton team have been working on for, I think, maybe more than a month. I don't remember when we started on this. Gluon is something that the team has been thinking about for a long time, and what it really is, it's a new language, but it shares the same front end and compiler as Triton, and so it's the same layout technology. It's the same compiler, but instead of targeting this kind of high level representation, it goes straight to the back end. So Gluon skips the middle end. What this means is that it exposes a lot more things in terms of what ends up being in the final kernel. This is like layouts. This is broadly speaking scheduling, but really what this specifically means are things like asynchronous ops and warp specialization, and exposes shared memory, tensor memory, and lower level hardware features that you can play all sorts of performance tricks with. What's important about Gluon is it maintains the tile-based programming model of Triton. So it's still you're still playing with tiles and storing them in and out of memory. But now it's a lot more aspects of the language are exposed, or a lot of more aspects of the GPU are exposed. So the kind of motivation here is that over the past couple of months of working on things like warp specialization, loop optimization, and as the kernels are becoming more complex, it's clear that getting kind of out of the box performance that is same order of magnitude as what you would consider to be peak performance is becoming very difficult in the Triton middle end. Some of it for purely combinatorial reasons, and some of it just because of practical engineering reasons. But so for example, warp specialization on Hopper, really there's not much wiggle room in terms of what you can do with the schedule. But on Blackwell, some of the schedules are frankly quite complicated, and it's the kind of stuff that a compiler would really struggle to figure out. And a lot of these schedules are like, you either have that schedule and you have the performance, or you don't. So there's a pretty big cliff if you don't like really squeeze all of the memory and registers into this like perfect puzzle piece. And so for a lot of these cases, it's kind of out of reach of like a reasonably behaved middle end. Layout assignment also is like a constant kind of back and forth between, changing heuristics in the compiler and, working on kernels. So another reason why we want to get the middle end out of the way in some of these like edge cases for performance is so that someone who is trying to squeeze performance out of a kernel doesn't need to, edit the compiler or bug someone on the compiler team and wait like, a couple of days for that cycle. And so hopefully this should provide like a tighter performance optimization cycle for people working on kernels. I kind of like, this is like my personal opinion, but I kind of feel like Gluon is like a systems programming language for GPUs. And the reason why I call it that is because like CUDA C++ is effectively like writing assembly. And the reason it's like writing assembly is you have this global state management of like how much shared memory, you get a block of shared memory and you have to like reuse it in clever ways and, partition it into tensors and so forth. And so this when you're writing CUDA, there's this kind of like global state management that makes it feel like you're writing assembly. But in Gluon, you still have this like a lot of abstraction coming from the Triton backends. You still have the shared memory allocator, fence and barrier insertion, and importantly, the LLVM code generation, which is essentially the tile abstraction converted to SIMT. And so Gluon essentially replaces the role of the Triton middle end when it comes to performance. So there's obviously like trade-offs that come with this. It's not portable. Kernels, I'll say that with a bit of an asterisk, but like for the most part, the language is not portable. Things like tensor cores, you have to access the specific instructions, and this is not going to be portable forwards and backwards across different hardware generations, obviously. It's definitely like more difficult to write because in order to use tensor cores, you have to manage the shared memory and like synchronization yourself. And it requires hardware knowledge to write, whereas Triton is like all of that is abstracted away. So in Gluon, it's definitely a much lower level language, and it comes with all the trade-offs of having a low level language. So the progress so far is that, and Peter did the vast majority of the work of bringing up the language. There's some front-end refactoring. The actual like core language semantic itself is mostly just Python bindings and a small API layer on top of them for the back end of the compiler. There's a couple of like core Gluon types like shared memory descriptors, barriers, etc. And we've also made the front end a bit more powerful because the kind of kernels that are being written in Gluon are a lot more complicated and generally like more code and require more abstraction to write in a clean way. And so far, there's like, we're focusing on Blackwell, but there's a bit of Hopper support. The way we dog fooded kind of our own language was we tried to write a forward multi-head attention implementation. This was like the kind of the straw that broke the camel's back for the middle end, which, to get peak performance for this kernel, there's a very like specific set of tricks you need to do with warp specialization and memory reuse. And so this was kind of the main thing we were iterating on in order to like dog food the language, and the results are like pretty good. It's back and forth, like, there's a bit of back and forth as I was refactoring the kernel, but kind of the best results so far is it gets about like pretty close to 800 teraflops for D64 and can get pretty high on D128. Still slower than QDNN for various reasons, but I think these results are like much better than what we were getting out of just the Triton middle end, and like especially for D128, it's like significantly better than what we were able to get out of some various middle end optimizations. So the language I think is in pretty good shape because this is a reasonably complicated kernel, but a lot of things are just being added as needed, and so we expect to continue to evolve the language in lockstep with the kernels that we write with it. So the future work is like, Gluon is like very, very new. It's like very fresh out of the oven. It's very experimental, and like as we use Gluon to write more kernels, probably many things will change. So right now there's like one kernel and a bunch of unit tests. As we write more kernels and discover more limitations in the language and in the APIs, we're going to add and maybe remove more things. The kind of biggest feature coming out is that there's going to be this new feature for better layout management. So if it's not obvious, like in Gluon, you have to set the layouts like and manage it yourself. And depending on the kernel, this can get like quite annoying, and like can get out of control very easily. So we're going to add a couple of like features into the language to make this a bit easier. And mainly, it's just like exposing things as needed. We were exploring like adding mutability to the front end, and there's some kind of back and forth discussion on this. May or may not go anywhere. But the important thing is like we're not really planning to accept significant contributions at the moment, but like, you know, minor fixes here and there are always welcome. But do feel free to try it out. All right, any questions?
Don't all raise your hands at once.
Yeah, I have
Okay.
a question in general to the approach. So Gluon is basically for a particular generation of GPU. So you will have to add new. Is the goal to have the language feature stable for different generation of just NVIDIA GPUs, or you would have to rewrite the abstraction, the language or new operation to target every new generation, because you might actually have new hardware feature that you want to expose to the user. So you may actually need to add so that there's a significant rewrite to support any new generation of GPUs.
I would say that you wouldn't like write the kernel from scratch. I think that moving from one generation to another is like the answer is yes. You do have to rewrite the kernels because if there's new hardware features, there's like no magic that will have your kernels use them by default. Even in regular Triton, you know, with tensor descriptors are now backwards compatible. You're only TMA on hardware that have TMA, but on Gluon there's no portability, and so when you move from one hardware generation to the next, it may work with only minor tweaks, but most likely, like if you want to squeeze performance out of the new generation, the kernel may look very different anyways.
Yeah, okay.
The other thing I forgot to mention is that a lot of kernels have like many bells and whistles on like what they can or cannot do. And when you write these kernels in Triton, it's like almost like a declarative specification where you kind of like enable the features you want, and the compiler will figure out the best way to schedule the program. In Gluon, you don't have that. And so if enabling certain features in the kernel results in like a different performance considerations, you may end up with a very different looking kernel when certain features are on or off. And this is either going to be challenging to like meta program in the kernel, or you might end up writing with like a handful of different versions of the same kernel specialized for different cases.
Thanks.
Hey Jeff, looks like I have Puyan. Puyan there?
Yeah. Hi, Jeff. I'm wondering, do you imagine that in the future certain Triton ops might be implemented using Gluon rather than in the compiler itself? I remember like a year ago, the TL histogram was added. If Gluon were there, do you imagine something like that could be just written as a Gluon kernel and invoked that way?
Probably not. I think they're very different, right? So these kind of like the Triton ops are tile level. And so to go from like tile level to SIMT level, there's a lot of like optimization tricks you can play with like warp shuffles, shared memory, and like moving registers around. That stuff is not exposed in Gluon. And so there's probably no like Triton primitive that you could write in Gluon. That being said, the idea of interop between Gluon and Triton exists. It may or may not ever get done, but the idea does exist.
Oh, cool. Okay, thank you.
All right. Adnan?
I think from what you said, Jeff, like you're pushing some of the onus of things like scheduling onto the kernel writer. And in that case, is there tooling that you foresee that will help guide the kernel writer? So some of the stuff that's been done recently, for example, with timeline views, are there other things like that that can help?
I think definitely improved tooling here. I'll call it two specific things. So I know some folks have been working on intra-kernel profiling with Proton. I think that's actually going to be really important for some of these complicated kernels. Because if you look at the NCU stall counts, it's like not actually obvious anymore where the bottlenecks are, depending on the complexity of the kernel, by just looking at the stall counts. Because like a very high stall count of 30% could actually mean nothing because it's not on the critical path, or it might mean something, but it's like hard to tell. If like a dependency graph of the program is like highly complicated, it takes a bit of like backwards thinking to figure out where the bottleneck is, and it's definitely non-trivial. And so something like actual like timing parts of the kernel would be super useful in providing more visibility into the performance. Another like pet peeve that I will like specifically mention, but it's something that we hopefully plan to address, is that there's a lot more function calls in Gluon, and like functions getting inline, but the debug info doesn't actually show the full like function calls inline call stack when you're debugging in CUDA GDB. And so this is like a major usability issue right now. But you know, when these issues get resolved, I'm pretty optimistic that the tooling will be good, and like performance profiling and iterating will actually be quite smooth.
Okay, this is something we're very interested in also, and I think it'll be a good collaboration point. So thanks.
All right, thanks, Adnan. Off to Simon.
Yeah, I guess following up with a previous question, it does seem like there might be this might be a methodology where you might use this as for instance, like a microkernel just for the hot loops, or just, you know, where you really need that fine-grained detail. Is that what you envision for interop between Triton and Gluon?
There's no concrete vision for interop. It's just kind of a vague idea.
Okay.
If I had to like make things up, I would say that if you had a sufficiently large kernel that to the point where you actually had like distinct hot and cold sections, it may be worth thinking about. But at the moment, the kernels are that at least that we've been playing around with Gluon, like are not that large that writing the cold sections in Gluon is like a pain.
Gotcha.
All right. Any more questions for Jeff? Jeff, I was kind of curious about something. Is anybody doing any work with AMD or any of the other processors using Gluon also? I know your folks are doing things purely for Blackwell. Just kind of curious if there are other processors, not just simply Hopper or Blackwell.
So I'm not the authoritative voice on this matter. Supporting AMD and Gluon is like as simple as adding the bindings and like, you know, adding some Python code. Mm-hmm. And the rest of the infrastructure can be reused. You can directly target the AMD backend for Triton. As far as concrete plans to do that, I think we probably will do it, but it's like things are very early, and we just want to keep the scope as small as possible and focus on execution.
That makes sense. That makes a lot of sense. All right, folks. Looking around the room real quick, do we have any last minute questions for Jeff? I want to say thank you very much, Jeff. I know this was kind of a last minute ask, and you know, I really appreciate the fact that you ponied up and actually gave the presentation.
Yeah, no problem to talk about it.
Okay. So if there's no other questions, we will go on to our last topic, or next to last topic, which is interest and requirements for nightly performance regression suite. And Simon Waters, who you've just seen ask a lot of questions, is going to give a little chat about that, his proposal, and see if we can get some feedback on that. Okay, Simon?
Yeah, thanks. Actually, Brian is going to help me with this. Brian,
okay.
So just following up on the conversation from last community meeting around nightly performance CI. This is a topic that's very near and dear to my heart. Spent a couple of years at AMD working on the Triton compiler. And one of the, of course, frustrations that we had was, just lots of performance regressions that would just sneak in either from our side or upstream, or from just general Triton optimizations or our own. We just didn't have a real good infrastructure, and so we worked very hard to put something together, but had a lot of challenges with infrastructure and whatnot. I understand the team is making a lot of improvements there, and things are coming online. But it's just hard to do performance optimizations generally when you don't have a good sense of where you are from day to day across the suite of kernels and data types and different hardware, right? Different architectures. So Brian is working with me. Brian led the AMD NPU software team at AMD as well. And he's going to talk about some ideas of how we could help and just see what the community thinks about that. So go ahead, Brian. If you're talking, we can't hear you.
And you're unmuted, so it's okay. So there's something else going on.
How about that?
That's good.
All right, there we go. I'm online. So there was a conversation last community meeting in May about, wouldn't it be great if there was regular profiling data that everybody could access? And I mean, there is some concern about finding resources to run on and figuring out where they could be outside of companies or shared or something. How do you store and track the data? And then there was a request for help. So this is something like Simon said, both of us have managed teams dealing with all of this. We totally understand how important this could be. So our proposal, and I'll give you a picture on the next slide. We can provide like a cloud-based NoSQL server, somewhere to dump the data, and then everybody can access the data. And we could also provide some simple analysis tools. I think probably the easiest thing is to take what is in Triton Bench already and expand it, so we can also help with developing tests. I mean, we need this stuff ourselves also, and we don't have quite the same restrictions on putting stuff out publicly. So we can certainly publish what we're doing. And also, if there's interest in the community, we're willing to spend a little bit of our effort to help out the community and share results and take some guidance on, what do you want to test, how often, what devices, those sorts of things. I think probably the easiest thing for support for something like this is put out a user-facing Discord, just so people can chat about it. Slack here is great, but sometimes it takes a little while for people to get access. So if you have somebody out there that isn't in the Triton Slack, they could just pop in and ask questions, that kind of thing. What it looks like, it's pretty much like this. So kernelize can take Triton Bench, run it regularly, expand it with tests that we need and tests that the community is interested in, or you can contribute however you like. To start off, we can run in AWS. I mean, we'll talk about resources in a second. That would be dumped in a database. If somebody else wants to contribute to the database, we can give you an API key or a login or whatever you can contribute. I do want to limit this, like just mostly to keep things clean, but certainly we're open to other folks if you want to put data in here. Again, it's open. Anybody who wants to read it can read it. And then we can also provide a website that reads the data. And I'll show you the website just briefly. I'll preface this with, this is all fake data, AI generated, like there's no real data in here. But we could do something, we are thinking something based on PyTorch version, just on the main page to be like version to version, here it is. We can provide a login would let you kind of customize that to other things. If you're interested in operators, and again, like all AI generated, here's an ADMM, how's the MI300 doing? And it could give you a graph over time. I think that's one of the things we really want to track ourselves is like performance data over time on an operator, on a kernel, on a device. What's the best I don't know, lowest memory. I'm not sure what, again, these are kind of made up metrics, but lowest memory, lowest latency kind of thing that you could view over time. And it's all just sitting in a database. It's easy enough once the data is there to modify the graphs. You could have a big table of stuff and filter and search through if you have more detailed information you want. Maybe we could provide a dashboard, not so much for private data, but for like if you have something you're working on, you could kind of lock into that. We give you a login and it would remember you, and you could kind of, I don't know, focus in on the things that you want. So pretty simple so far. Not that hard for us to build out. I think the harder part, if I jump back over to this, is resources, right? So we can contribute to people, right? To build things out, provide the database. We're happy to have a discussion. I mean, we can start it here, but it might get long. Like, what do you all want to see available? The request we're making to the community is to help us find somewhere to run this stuff. Like, we can do this to get started in AWS, but there's probably a better way, resource-wise, that the community can find to run this or share the cost or something. And if you have any questions, feel free to email me. Things that we're thinking about would be like, what's the list of tests are important for profiling? What kind of data types do you want to test? What hardware? Are we doing unit tests mostly on kernels? Are there full models that matter? How often do you need to test? Probably nightly. Some stuff needs to run. Full models, maybe not so much. And getting access to a B200 is kind of a pain. So, the kind of hardware you run onto might be something to consider. So if you folks are all open to it, I mean, I'm happy to answer questions now, or we can talk offline with anybody who wants to kind of dig into this a little bit more.
All right, Simon and Brian, are there questions that folks end up having or might have? I've got one if nobody wants to ask the question is, do either of you have experience working with self-hosted runners? Because I think one of the ways that you might be able to get more traction or get more people to actually want to participate is if we can figure out a way to make things very secure. Because I think that was the biggest problem that everybody else brought up when I brought up this same point is like, okay, so how are we going to actually run these things in a really secure environment? So that's if you got an answer for that one, I think that's kind of like the big one that would like unblock a lot of things.
So self-hosted runners in the sense that you're running in your own I don't know, in your own company and then providing data out, or what?
That's true. Or even if you were to work on AWS to make sure that we have some type of bounds about like what resources are available for the person who wants to run the test, to make sure that people aren't doing Bitcoin mining and disguising it as a test, so.
Yeah. Okay. We could talk about self-hosted runners. We were thinking more that we would manage this more like a cron, and we would just talk to folks about what they want to run regularly. But yeah, if you want to talk about self-hosted runners, we could talk about that. Like we're able to do that. Yeah.
We do have some partners who are more expert at that kind of cloud-based
cloud stuff. Yeah.
Good,
definitely. Good. Yeah. I think there was a question somewhere.
Cece.
Yeah, I was wondering, like, have you had any tests that stood up that has run? And you mentioned the results are all like AI generated. Is this a concept, or do you have something that's already running?
Yeah, I mean, we have run Triton Bench, and we have the ability to push data into Triton Bench, but the scale that we're running at right now is like 10 tests, right? Before we scale up, we really want to talk about what do you really want to test. But yeah, this is all real database. We have a Python script that will really write to the database and add data every day. We're just not sure what to run.
I see. And what is the business model for what you're trying to do? Like,
no, this is not a business proposal from
okay.
kernelize. This is for the community. I think if we get into something where we have to protect your data, we would need to have some kind of contract with the company who we're protecting data with. But for anything that's publicly open, no problem. Like we can provide it to the community.
Okay. And I know we were having some challenge getting test run on Blackwell because it's not very widely available. Are you going to be able to get access to it, or that's still an open question?
it's expensive, but we have access.
Working on that. Yeah.
Okay.
Yep. But yeah, I mean, the problem with Blackwell is at least in Amazon, you have to purchase a time block, right?
A capacity block. Yeah.
So who's paying for that? Like you're proposing can run this, but
Well, that's a good question.
We want to talk about, like, can we find a way
Okay.
in Amazon to run this stuff? Like, we can bring it up on Amazon and pay for that ourselves, but that'll get expensive over time.
Yeah.
We'll find a better way.
This sounds like something we might need a consortium for, to actually have people actually chip in, and like, we actually buy like help, like Meta, Intel, Microsoft, OpenAI would actually contribute to that. Probably doing something similar to that.
Yeah, or maybe we can give you a secure way to run in your own cloud, because you're only exporting like a CSV file at the end, right, into the database effectively. Yeah.
That also brings up the I guess to go to, like, I don't know if it's Cece's point, but there is this idea that our systems may be configured a little bit differently than everybody else's ones, so that there is a flavor of MI 300 or an MI, a flavor of an MI 350 that kind of looks different on our side than other sides. So therefore, the benchmarks might be different. Mm-hmm. So just kind of curious if, like, you're thinking of actually including that type of additional information also about, like, where it did run, who actually provided the actual source data, because I can imagine, like, if you can't just simply aggregate it saying, oh, it was just for 355, so they should all look the same. They don't necessarily look the same, because they might be slightly configured differently depending upon how they actually stood it up inside their data center.
Yeah, exactly. And do we want to have? I mean, yes, exactly. How you configure everything.
So you want to pin the frequency and things like that.
Yeah, I mean, this is really the conversation we want to have offline before we dive in. I don't want to go run a bunch of tests.
Oh, yeah, definitely.
Well, we don't really know. Yeah.
Okay, Xu.
Yeah. Hi everyone. I'm the owner of Triton at Meta. Thank you, Brian and Simon, for giving the presentation, and excited to see that Triton is being used. I just want to share a bit about my experience of setting up the Triton AI at Meta. So we are hosting under the budget of the PyTorch open source team. So I get some H100 quota from the entire PyTorch dev infra, and then I set up a Kubernetes cluster on Google Cloud with auto scaling, which means when there are more benchmarking jobs coming in, it will automatically increase the number of runners on Google Cloud, and when it's more idle, it will kind of automatically scale down with smaller runners. Right? This is how I did. So if you are interested, I can maybe we can share more offline. And also, another comment I want to make about the UI is I feel like we need some kind of A/B testing UI, right? So because a lot of times we want to run some maybe a customized branch of Triton, or these kind of experimental branches or experimental repos even, right? And then we want to see, okay, how many of our Triton bench test regresses or speed up.
Yeah, for sure. And so I see that in Triton.
Yeah, it'll be a very useful feature.
Yep.
All right. Any other questions? Otherwise, we have Brian's. I think we have both Brian and Simon's email. So I think if you want to reach out, Brian, maybe you want to set up something on Slack, or I guess you said you want to set up something on Discord. If you want to publish that more around to me, I can try putting it together, and we can stick that on one of the community announcements to let people know.
Yeah, I think that was more of for Discord. We can set that up in the future to support folks. I think the Triton Slack is good place for now. Okay. If you want to reach out there, that's great.
Yeah, because there are some people who are joining us from GPU mode, and we'll probably cross-post it there also, because some of the GPU mode folks might want to actually participate too.
Mm-hmm. Yep, sounds good.
Excellent. So now we've got about 9 minutes left. We don't have to take the full time, but if there are other subjects that people have that would like to present or would like to talk about, raise your hand and I will give you the floor. Otherwise, we might end up a little early. Okay, 3, 2, 1. All right, folks, thank you very much for joining, and really appreciate all this. The recording will be available really soon, and once again, the notes will also appear online too. Thanks all.
Thank you.